Hello everyone, we are Team Deep Sea and we would like to introduce to you our design for DeePow Automatic Snowboard Bindings. This is our response to the prompt, how can we make transportation safer, more comfortable, or more efficient?
If you've ever been snowboarding or even skiing with a snowboarder friend, you know what a pain it is to have to sit down in the cold snow and strap into your snowboard bindings before every single run. We decided to automate this process by creating a binding that senses when your foot is inside it and automatically tightens for you.
Our clients are the DeePow Autobindings and snowboarders, and those who specifically seek to make strapping less tedious. We wanted our users to be able to tighten their bindings without sitting down. Furthermore, we wanted to expedite this process as a whole by reducing the time needed to complete the action to under 5 seconds. By incorporating electronics and circuitry into our design, we are exploring uncharted territory when it comes to snowboard binding automation and making this recreational activity more enjoyable as a whole.
Throughout our design process, we had a few critical decisions to make. The first was to model our design after the flow binding by having the back of the binding release instead of the front straps. We decided that this would allow for greater simplicity and consistency in our design due to the backing having a more restricted range of motion. Our next critical decision was choosing what type of motor to use for our design. After considering both servo and stepper motors, we decided to use a stepper coupled with a worm gear which would support the back mechanically rather than just with the torque of the motor.
Here we have a block diagram of the functionality of our product. We begin with the bindings in an open position, meaning that the back piece is parallel to the ground, allowing the foot to slide in. Once the force plate senses over 50 pounds, it triggers the stepper to rotate until the back piece is upright or perpendicular to the ground, securing the foot in. Once the user presses the button, the stepper rotates the opposite direction until the back piece is back in the open position.
In this model of the circuit for our design, the backing of the snowboard binding is shown as a servo motor, and instead of a force sensor, we have this photo sensor here. Now when the photo sensor, or force sensor, would sense 50 pounds of force or more, the backing of the binding would close, and when the button is pressed, the backing would open.
This is a pre-designed snowboard binding that we found on GrabCAD. The highlighted yellow parts are the only parts edited to fit our model. The remaining parts would still be attached and functional with our design.
By using Onshape, we are able to simulate how the physical binding will actually work. As you can see here, we have our motor casing, our stepper motor, our worm drive, and a couple shafts. So from the simulation, we see that once you grab this back piece, the motor will be spinning and the worm drive and the gear will also be spinning alongside with it. And the program also does not allow for the binding to go further than this point right here, so it is in a locking position.
If we were to continue this project, or have a chance to do it again, we would certainly have a few things to do differently. Of course, had we been able to build a physical model of our project, we would have had a very different prototyping experience. However, even in this virtual version of the project, we could have made improvements to our process. We all agree that integrating our individual CAD designs with one another earlier would have helped us recognize problems sooner. Instead, we spent too much time working separately and as a result had to make many late adjustments to our parts so that they would work together properly.
While Deep Sea started off on a great foot with the introduction project, genuine team growth occurs when unexpected obstacles arise. While nothing compares to the experience of designing, iterating, and building a project with a team in person, we have learned valuable lessons from this trying time. We have learned to emphasize immediate communication, improve organizational skills, and to be thorough inquirers. In-depth questions allowed for a better understanding of our virtual design, as we could not physically explore our creation. Although the semester may be coming to a close, the enduring lessons and developed friendships will remain.